to Minds of Machines, where the future of learning meets the power of code. Ever imagined a world where bots teach you how to code? Well, the future is now. Dive into our series of Python tutorials guided by our very own self learning bot. Whether you are a coding newbie looking to dip your toes in the world of programming or a seasoned developer eager to explore the wonders of Python, we have got something for everyone. Our bot not only teaches but learns with you, adapting to your pace, answering your queries, and ensuring you grasp every concept with clarity. So, gear up, dear learners, embark on this unique journey with us as we unravel the magic of Python, one line of code at a time. So, let's start with the second part of this tutorials on bots. Don't forget to hit the subscribe button and ring the notification bell to stay updated with our latest tutorials. Let's code, evolve, and transform the minds of machines together. So first, as you can see, I have created a folder called as self-learning bot in which I have created two files. First one is data.txt which contains the data which we are going through which we are going to make our bot learn, and second file is the supportbot.py. So here we will be writing the logic for the self-learning bot. So the very first thing I will do is I will import the file numpy library, which is essential for performing numerical operations in Python, and we are giving it as a shorthand as np for easier access through our code. Next, we are going to import the NLTK library, which is a toolkit for working with human language data and provides easy to use tool to help programmers work with linguistic data, analyze it, and even build applications like chatbot or sentiment analysis tool. Next, we are going to import is the string module, which contains common string operations and properties. After that, we are going to import the warning module that helps us manage any warning messages in our program that might occur or generate. Then we bring the random modules, which is essential for generating random number or making random choices. So this is the libraries we are going to install, and then we are also going to import the text processing library, which is basically used for English stop words, which gives us common words to ignore. And then we are going to also import the TDF vectorize that helps to convert text into meaningful numerical data, as bots don't understand the meaning of what. So here we are using the this library to convert into numerical data. Then we are also going to use the cosine similarity function, which helps us to measure how similar two text or documents are. Next, we are going to the data text file where we are going to copy our data and paste it. So this is the knowledge base for our self-learning bot. So I'm going to copy it and I'm going to paste it, as you can see on the screen. Once I've entered the data, I will save it. Next, I have to read this data for my bot program. So what will I do is I'll write f equals to open bracket. I will enter the path and then enter the command and then tell it to ignore the errors while reading the data. So we are kind of reading the data and storing it in the f variable. After that, we will read the entire file and store it in a variable called as raw doc using f dot read function. Once that is done, next we are converting the entire raw doc to a lowercase for consistent processing, because sometimes it can be case sensitive, so we are trying to convert, or you might enter, so anything which the data is in any format, we're just bringing it in the same case. So here we are converting into the lower case. After this is done, we need to even download few essential data sets from NLTK to for our operations to perform. So what we will do is, so we will first download the Punk KT tokenizer that helps in splitting the text. Then we will download the WordNet, that is dictionaries for semantic operations, and the OMW dot 1.4 for multilingual WordNet access. Next, we are going to do is, we will define sentence tokenize equals to nltk dot sentence tokenize bracket raw doc. This statement basically does is breaks the document into individual statements, then thinks of it like a splitting a story into its chapters. Next, we are going to use the NLTK library for word tokenize. Here we are chopping the documents into individual words, imagining cutting a string into beads. Then lemmatizing or wordnet lemmatizing. This is a process, or this line prepares a tool called as lemmatizer, and it's like a grammatical wizard that turns words like running into run. After that, we are going to remove the we are going to remove the punctuations. So in this line, we create a dictionary to remove the punctuations, like comma, dot, and imagine it filters that it's a filter that catches and removes all commas, periods, and other symbols. Next, we are going to define a function called as lem token, in which it will which has a uh, token in which we are going to pass the token whenever we call this function, and inside that we are going to return their base. For example, it's like if the token is running, then it'll become run, so it converts into base form. After that, we are defining one more function called as lem normalize bracket text. This function cleans up the text and it makes it lowercase, removes the punctuations, and gets base for each word. Next thing we are going to do is define the greet inputs. These are the words or phrases you can say to the board to start a conversation, like saying hello to a friend. The next is greet response, like hi, hey, hey there, there. So when you greet the bot using one of the greet inputs, it picks randomly a reply from these opinions to greet you back, just like the friend saying hi in the written. Then we are going to define the greet function, which it takes a sentence as a parameter, and it does is this function checks if you said in greetings like hello, and if it is, the bot picks a random greeting to reply back to you. So if you say hi, the bot might reply with hey or hello randomly. Next, we define the response. So in that we define robo response, which means we start with an empty response from the bot. Then we define with warning catches warning, which is like a filter that will ensure that any technical warnings are hidden so our bot runs smoothly for now. Then we have used next statement is to clean all the stop words. So what we do is we want to not have stop words like and the, which do not add any meaning. So here we are just removing those words using lem normalize function. Then after that we are using the TDF vectorizer, where we are passing the tokenized word, and we are also passing the pre-processed stop word, and here we are calling a tool called as TDF vector. Think it's like a magical box that helps a bot to understand the importance of word in a sentence, and we are telling this tool to clean up the text, which are lem normalize functions, and to ignore common words like and the or is using the processed stop words. After that, we are going to use the TDF vector dot fit underscore transfer bracket sentence token. This line is teaching our bot to understand the importance of each word in a conversion and think of it's like a highlighting the most important word in a book, so the bot knows what's crucial. Then what it does is we are now measuring how similar our last message is to all previous message. Think of like checking how close 2 points are on the map. Then we are finding out which previous message was the most similar to our last one, and it's like finding the closest store to your house on a map. Then we are turning our map distance into a straight line, making it easier to see which one is the shortest. Then we are arranging the distance from shortest to longest, just like arranging the books by their height. Then we are picking the second shortest distance, imagining the picking the second smallest book from a shelf. So this gives us more accurate result towards the question you ask. So whenever you ask a question, so it compares the word from your questions to the words in the text which it has converted into number. So the second closest numbers always give you an accurate answer. That is why we have selected the -2. We check if it matches or not. If the board doesn't find any matching information, then the req underscore tfidf variable will be 0, and it will be imagining a purple elephant on Mars, and in a book about a cat, and the book is about a cat, and the book has no idea about the topic. So robot will respond that I'm sorry, I'm unable to understand. So then the same way, if else part, if the bot does find something response, then it will read the sentence token and add it to the robot response and will give you the response. So if it is -2 or minus if it finds any integer lesser than 0, then in that case the value will be, or your response will be seen, because it was able, the code is like a mini search, and if it doesn't know the answer it will apologize, and if it does then it provides you the information. So this is the main logic of how your robot self learns itself the content which you have provided in the data.txt and gives it to you. So this forms the main brain part of this code. Next part is we have to start the main conversation part. So this is where we wrote the brain or the main logic part of our learning board. Now next we will be starting or writing the logic of how the conversation will be there or how it will start. So first we have defined flag equals to true. Think of it as turning the chatbot's power button. As long as it is on or true, the bot will keep chatting with you. Then it has to greet. As soon as the bot is turned on, it has to say hello and tell you how to start and end a conversation. So we have printed the a statement in which it gives you guide how you have to start by saying hello and how you have to end by saying bye. Then the next part is you will get the user response. So the bot waits for you to type a message and then reads it, and it also turns your messages into lowercase to understand it better, as we have defined before. Then if the user response is bye, then it would say and if you say anything other bye, the bot will continue the conversation, otherwise it will turn off the chatbot. Then it checks if the user response is thank you or thanks. In that case, it will reply with a kind message and get ready to end the chat. That is, if you greet user responses none, then the bot will select one of the replies from a greet. The bot checks if you said a greeting like hello, and if yes, it replies with a greeting. So this is how the thank you part works, and we will switch it off as flag by setting it false, so it will then print like support bot, you're welcome and always happy to help you. And if you have not said thank you or bye, in that case it will actually perform the main operation for which we have designed, that is answer your query. So first, the bot does is saves your message. It is like if it checks that then you may say hi, hello, or anything like that. Then it will respond from its messages saying hi, hello, as you can see below. Or else, if you have not said any greet response, which is none, in that case it will first, the bot will save your message. If it is not equal to none, then it will greet you saying bot greet bracket user response. Now since we have greeted and everything is done, the next part is whatever you say, the bot will save your message to remember the conversation. Then it will break your message into individual word, like splitting the word or sentence I love pizza into I love and pizza. So if you're there's some question like what is the returning policy for so and so brand, so what returning policy of so and so brand into different words, so it will do that. The word tokens does that to the word. Next, it will create the final list. The bot then makes a unique list of all the words it has seen so far, removing any duplicate words. So finally, it creates a list of the words which it has seen which it has seen based on cutting it. Then it will go to the response function, that is the main logic over there. It will perform the function and give you the response, that is what response which response matches to the word or the list of words which it has passed to the function. So based on that, or the final word it has prepared, it will send it to the response, and over there this operation will be performed, and then it will give you the response in the form of print. Then after replying, the bot want to forget your last message to keep the conversation fresh. So now, and that's how our bot processes and responds to each message you send. And if in case you say bye, in that case we set the flag as false, and we show the message as support bot goodbye. So this is how you write the entire code for creating a self-learning bot. You can do certain kind of variation in this code depending on what your requirement of bot is and what all functions you want to use. There are different way of creating a self-learning bot, but this is one of those techniques to create the self-learning bot. Now let's see how it is seen in the terminal. So now what we will do is we will run the program python 3 support bot, it will download all the packages. As you can see, it is showing, hello, I am the support bot. Start typing your text after greeting to talk to me, and for ending, convert type bye. So if you say bye, I will end the conversation. So it's explaining you, as you can see in the code where I've defined the first statement when I switch it on. Then after that, I will say hey, hi. Then it says hey there. That is, it is getting from the greet response, because it comes at greet user is equals not equals to none. Now, next thing is the main part of this bot. Here I am talking of a normal luxury brand. So I'll just type, I want to know about the brand, and I'll put the brand name. And then it says whatever it finds nearby. So it says, when it comes to customer policy, Alcine Glow offers a 30-day no question asked written policy. Then after that, I will pick one of the words from this data, so to show you how this TDF vector works. So I will find, as you can see, I will select one of the words from the code, from the data above, saying what is Axior radiance serum. Auxiliar radiance serum. So this thing forms a main word, and it will actually give you the response same as mentioned in this text, because the word starts from here, and it will do the TDF vector and then get the score for both the words, and then find the cosine similarity, and then it will select the entire statement from the data.txt, and it will show you in the terminal. So based on the second smallest value in the after doing cosine similarity function, after applying the cosine similarity functions. So this is how the support bot works. Then I will just enter bye, and my support bot is switched off. So this is the overall working of the self-learning bot. So alright everyone, this brings up to the end of today's tutorial. I really hope you found this useful. As a quick recap, today we covered about how to use cosine similarities, and how the data are converted into numerical format, and how your question is converted into numerical format and compared with the and is and the answer is identified by finding the least distance between those two, between your question and the data which is converted into numerical format. So, if you have any questions or run into any challenge, please don't hesitate to leave a comment below. I will do my best to get back to you. And if you have enjoyed this video or found it helpful, please give it a thumbs up. And if you haven't already, hit that subscribe button and ring the notification bell so you won't miss any of our future tutorial. Also, don't forget to follow us on Twitter, Facebook, Instagram for updates and more tips. Stay tuned for our next video, where we will deep dive into the next type of bot, that is advanced version of bot. Trust me, you won't want to miss it. Once again, thank you so much for watching this, and I am signing off. Take care and see you in the next video.